Hello, welcome to the introduction of ADSML, a tool for autonomous driving scenario modeling, simulation, and analysis. First, before the tool demonstration, let's take a look at the functional scenario descriptions. Case 1 shown as in this PDF. This scenario contains two vehicles. Vehicle Eagle and Vehicle F1 are in lane 2. As the training vehicle, Vehicle Eagle must stop in the time or change lane if allowed to avoid the imminent collision. The maximum speed of Vehicle Eagle is 20 meters per second. When Vehicle Eagle approaches Vehicle F1 and the distance between them is less than 10 meters, Vehicle Eagle will choose to change lane or keep following. Next, let's see how to use our tool ADSML to model scenario according to the functional scenario descriptions. ADSML has three buttons on the top of editor that correspond to the functions of storing the model as a JSON file, scenario simulation, and the model transformation. We can create the corresponding .model file and .tree file through the file menu on the toolbar. The former configures the workspace, vehicle spatial location, and the simulation settings through a simple set of parameters. The latter models the temporal development of the vehicle in the scenario based on driving behaviors, known as the behavior modeling in ADSML. In Scenario Parameters Editor, a file selector is provided for users to import custom OpenDrive map files, which is very convenient for designers. Of course, it is also possible to use the simulator's built-in maps. We designed the drop-down box and other easy-to-use ways to configure the scenario parameters. We built Kara's vehicle model, weather, and other options list into the tool in advance. In addition, a lightweight notion of objects are available in the editor, which allows users to add and remove vehicle objects quickly in the scenario. Objects are simply some maps from properties to values, and the users simply need to configure these properties according to the functional scenario descriptions, which is part of commitment to simplicity and convenience of use. For example, each vehicle contains a location property, whose values can store the precise position information. ADSML offers different strategies of specifying the location, including both absolute and relative positioning. We can bind a behavior model to the corresponding vehicle. The behavior model is comprised of a sequence of behaviors and triggers organized in a tree-like structure, which describes the dynamic process of a vehicle in the scenario. Inspired by the theory of state transition, we represent behavior as a state node, with directed edges connecting nodes and the trigger serving as the conditions. Here we only allow the state transition to be fired from parent to child nodes and start from the root. By double-clicking the circle, scenario designers can select a specific type of behavior from the built-in standard library and set the required and the optional parameters. ADSML also offers a standard library of trigger functions to represent events that can easily be expanded. The tool also includes probabilistic semantics for modeling the driving behavior that a vehicle chooses probabilistically. Like this, one can use different triggers with different conditions to explore scenarios with different parameter ranges and different distributions. After modeling the scenario according to the functional scenario descriptions, we can opt to simulate the scenario or conduct a model transformation for verification. We can choose to convert the graphical scenario model to a JSON format scenario model file by clicking the first button. This is the processed ADSML file. We provide two simulation types, a static scene display, a dynamic scenario simulation. Here we show dynamic scenario simulation. In order to save time, the simulation time is set to be 5 seconds. Here are the results of the simulation, the pictures, and the composite video. Now let's look at the second case. This scene is a little more complicated and consists of 4 vehicles, wherein F1 and B1 vehicles keep a constant speed. Vehicle F2 will accelerate and decelerate. The vehicle Eagle will chase car F1 and car F2 and change lanes as they approach. The behavior models of the vehicles are shown in the video. This is the converted XML file. We will open it in the OpenSMC tool. Here are the models. We extracted 3 safety requirements closely related to this scenario for analysis and verification. The verification results show that the probability of a collision between vehicle Eagle and F1 is smaller than 0.0981446. And the probability of vehicle Eagle keeping a safe distance from vehicle B1 during the whole overtaking process is greater than 0.901855. This is the display of our tool, ADSML. Thank you for watching.